Hey guys, in this video I'm going to talk to you about how we can represent situations in word problems with an equation or an inequality. And then by the end of this video we will also work on problems where they give us an equation or an inequality, and we can also so basically the reverse, come up with a word problem that describes the equation or an inequality. Much of the same stuff that we did on before the 3 weeks test. So these steps that you see in front of you, these are the 3 steps this is the solving process that you will use on every single word problem for this upcoming 6 weeks test. You don't necessarily have to do these in order, but this is the one that makes the most sense to me. And hopefully it will to you too. Okay, so step 1. Know what you're looking for. You cannot start any word problem ever if you do not even know what you're looking for. But we know how to do that. Most of the time it's the last sentence of a question or of a word problem. It tells you what you're finding. And these word problems are variable, whether it be X or whatever letter you choose, that's what we're finding. So whenever we, isolate our variables, which is another skill we've been working on, you answered the question. You found out what that variable equals. It will equal some number. But the first step to doing that is assigning it a meaning and know what you're looking for. Step 2, assign a meaning for all the numbers given. In the PowerPoints that we've been going over, usually 3 numbers are given. That will not always be the case. So if you see, a scenario where they only give you 2 numbers, that's okay. It won't always be 3, but most likely it will be. And I'll go over problems showing you where there's only 2 involved. But make sure that you assign each one a meaning. You can have, each equation is going to have the same numbers. The order in which they are in makes the world of difference, though. So make sure you're correct on assigning the meanings. And then the last step, use keywords to determine the operation, which is going to be addition or subtraction always, to be used, and determine which kind of equal sign or inequality sign. Remember, equal signs or equations only have equal signs. Inequalities can have one of 4 things: less than, greater than, less than or equal to, greater than or equal to. So make sure that you know which one you're working with. Okay, and then after you do that, your answers should look similar to this. I'm going to use these 2 sheets on every question I do. This should be seared into your brain by the end of this video. Should look similar to this. And this is from the last 3 weeks. It's just flipped. Remember y equals mx plus b? There's a meaning for each one of these letters. Almost every single question you come across will have a number replacing each one of these letters. All of them except x, because that's what we're trying to figure out. What the question wants you to find out. We don't know what that is yet, so most of the time that will just stay x. We will replace m with whatever rate they give us from the word problem. We will replace b with the starting value from the problem. That is the starting number in any scenario that they give us. And then y, most of the time total can work. Think of it as total value, but sometimes that can get confusing. So I like to think of it more as ending value. So b is your starting value, y is where we end up at. That's our ending value. And it will always it will always look like a form similar to this. On problems so to go back to what I said a few minutes ago, so most of the time there will be 3 numbers. There will be an ending value, a rate, and a starting value. But sometimes that's not the case. Sometimes there won't be a starting value. Sometimes you will only have a rate and an ending value, or you may not have an ending value, only a starting value and a rate. It depends on the problem. So that's important to remember. So now you know the steps to get there, and you know what the end result should look like. So let's go over a few example problems. Actually, not a few. I'm going to go over as many as I possibly can to get you ready for this test. I know it's tempting to think that, I've watched a couple, 3 problems. They're not going to be much different from each other. Well, these word problems can get pretty different from each other. A lot of them are pretty unique. So I will try to go through as many as I can, and hopefully you will stick with me through the entirety of this video. Okay, so let's go over one. And in class, I will try to have an anchor chart looking similar to the steps I just showed you. I may even upload those 2 notes on to my website so you can use those while you're working on these by yourself. Okay, number 4. Jake's paddle boat rides charges $5 per person plus $3 for every 15 minutes that a paddle boat is rented. If 2 people rent a paddle boat and pay $250 total, which equation can be used to represent X, the number of hours the paddle boat was rented? Okay, this one is fairly simple. They use a lot of language in here that gives you clues on what you're trying to do. So let's go back to our steps. Actually, no, I'll just use the page where I know what it's supposed to look like. Okay, so starting value, rate, total or ending value, variable. So I usually like to start with the starting value. Okay, so Jake's paddle boat ride charges $5 per person plus $3 for every 15 minutes. So right there I can tell a lot of information. They give us a rate and a starting value there. The total amount you will pay is $5 plus. So they just told us our operation. So right above plus, I can just write a plus sign. So it's not subtraction, it's addition. So $3 for every 15 minutes. So I actually had to pause the video there for a second because this one's actually kind of difficult, but not much more difficult than what you'll see on your test. So it's important to understand how to do this one. So we found our operation. Now we need to find our starting value. So they tell us how to figure out the cost, and then they give us a scenario. If 2 people rent a paddle boat and pay $250 total, which equation can be used to represent X, the number of hours the paddle boat was rented? Okay, so we know 2 people rented the boat. Well, they gave us a price for the price per person, and that was $5 per person. So we know that either 10 will be in our equation, or 5 times 2 will be in our equation. Because those 2 people paid $5 no matter how long they rented the boat. That is our initial fee or our starting value. Many companies or businesses or services will charge you a starting fee. Or that's basically your starting value. That's what they charge you no matter how long you use their service. That's a common business model to make money. So we can go ahead and write. So I can see my question, they've already got the 2 times 5. That's where that comes from, the 2 people times $5 per person. So I'll go ahead and write 2 times 5 is my starting value. Okay, and I know my operation is addition, so that's going to be plus. Now I need to figure out what my rate is. Well, they give us a rate. They tell us that the rate is $3 for every 15 minutes. Well, this one's a little bit more difficult because they want to know X, the number of hours. So they give us the rate, $3 for every 15 minutes. We have to convert that to how much is the cost per hour. Well, we know that there's 60 minutes in a hour. So all we have to do is multiply this rate right here by 4. Because 15 minutes goes into 60 minutes 4 times. Okay? So we can multiply this rate to be $12 per hour. Okay? And you can go backwards too. So if there was a problem where they wanted to figure out the price per 15 minutes and they originally gave you the price per hour, well then you know there's 15 minutes, or there's 4 groups of 15 minutes in 1 hour. So then you could divide it by 4 and get $3 for every 15 minutes. So it goes both ways. And I don't believe a problem like this will be on your test, but it's good to know the logic behind some of these harder problems. So if you know how to do these hard problems, you will for sure know how to do the easy problems. So we found our rate, and we know that X is the number of hours, so we can write plus 12X. Okay? And then let's see. And then that you see the word equation. They make it easy for you. You see the word equation. So you know you're going to use an equal sign. So we know we will have equals. And then going back to my b plus mx equals y, it's looking like it's turning out that way. We had a starting value, 2 times 5. Then we had our rate, $12 per hour. X is what we're looking for. X is the number of hours. And then equals, what did I say y was? Total, or ending value. We can find that in the problem too. So this is the one where you can think of y as total, because they say, and pay $250 total. So sometimes the language is easy for you. They make it very obvious for you sometimes. So we know our total or ending value is $250. Okay? Now sometimes they may flip things around in here, but you can just don't let that confuse you. If it's not in the exact order that I do it, it's not a wrong answer. It's just flipped around. It's still the same expression, just shown in a different way. Well, let's go through our questions, our answers over here. We know it can't be J, because 0.15 does not come in anywhere. 45x plus, that doesn't look right. 3x plus 15, that doesn't look close to our equation. The only one that looks close to our equation is f. And all they did was flip our mx and our b over here. All they are is flipped. It equals the exact same thing though. So that was number 4. Okay, so on to the next one, number 5. Now looking at the answer choices, you can tell that this one only has 2 numbers in it. So this is one of those. A football player can run 30 yards in 4.5 seconds. Which equation is used to find R, the number of yards he can run in a second? Okay, so it takes 4.5 seconds to run 30 yards. Okay, on number 5, you cannot use this form right here, okay? It's not very logical to think of it in terms of this. But what you can do is think of it in terms of a unit rate almost. From our unit rates have a denominator of 1. Well, in this one, our denominator is 1 second. Okay? So we know, they give us a rate basically in this one. They tell us that we can run 30 yards in 4.5 seconds. okay? And that will equal some kind of speed, some kind of unit rate. But only after we simplify it. So one of these equations will get us to this right here. Because if we divide 30 yards by 4.5 seconds, that will tell us how far we can run in 1 second. Because I'll show you why. So let's do that. So 30 divided by 4.5. Well, in order to get this denominator to be 1 to get it to a unit rate, we're going to divide both top and bottom by 4.5. So 4.5 divided by 4.5, or by itself, just gives us a denominator of 1. Okay? And this question really doesn't want you to figure out what r is, but 30 divided by 4.5 will tell us the distance in 1 second, so we can just say r. So in order to find out what r is, we had to do this. Well, one of these equations right here is the step before this. And the only one I see that is B. And I'll show you why. So let's say you had 4.5 r equals 30. Well, that's going to go to this, and here's how. If we wanted to solve for r, we would have to isolate r. We would have to get rid of this 4.5 that's on the left side of the equation. It's over here on the left. So remember, opposite operation. Divide by 4.5 on both sides. And that gets us to that, which we know will give us r. Okay? So it's kind of a convoluted way to think about it. But just know that if you were to solve for r, you would get the unit rate, which is basically what it's asking for. When it says in a second, that means in 1 second. So that's basically trying to tell you to find the unit rate. So in these problems, like these, it's not necessarily going to be a linear equation. We know y equals mx plus b. You just have to think about it logically. Okay, number 6. Which equation fits the situation? Mike's test score was 20 points lower than Mark's. If Mark scored a 95 on the test, which equation would give Mike's score? Okay, so this is a prime example of why we always want to assign our variable first. We know our variable is what we're trying to solve for. And remember, I told you to look at the last sentence of the question. So if Mark scored a 95 on the test, which equation would give Mike's score? So we know Mike's score is what we're looking for. So let's put, I don't know why they have P in there. Maybe it's for percentage. But let's go ahead and use the letters they use. So P equals Mike's score. Okay, so that's what we're trying to find. Now let's look at the other numbers they give us. This 95 and this 20 points lower. Okay, so we can find Mike's score because we know that it was 20 points lower than Mark's score. So we can show that we can find out Mike's score by, what's another word for 20 points lower? Minus 20. So we can write Mark's score, subtract 20 from it, and that will equal, and we know it's an equal sign because they say equation, that will equal P, or Mike's score. P represents Mike's score. Let's see if any of these answers in here represent what we just drew. 95 equals P plus 20. That might be it. Let's draw a question mark by that to see if that holds, if that's closer than any of the other ones. P minus 20. Well, G is saying Mike's score minus 20 equals Mike's score, or Mark's score minus 20 equals Mike's score. And that's clearly not what it says in here, so we know that one's wrong. Let's look at what H says. H says Mark's score equals Mike's score plus 5. Well, it was 20 points lower, so that can't be it. And then this says Mark's score subtracting 95 from it will give you a 20. That's not even close to what it's trying to represent in here. So we know that one's wrong. So by a process of elimination, it can only be if. So even though they didn't draw it as we did, it's the same thing. So let's say our variable is already isolated, but let's say we wanted to bring this over here. Well, we could just add 20 to both sides, and we would end up with, hold on, we would end up with 95 equals P plus 20. So mathematically that's what they did, but let's think about it logically in terms of the word sentence, or the word problem. What it's saying is Mark's score equals Mike's score plus 20 points. Well, that's the same thing as saying Mike's score was 20 points lower than Mark's. So they just kind of flipped it, but it's still equal to, you'll still get the same thing. Either way you write it, you will find P equals 75. So if you can, it will help you to actually find out what P equals at the beginning. So if we would have wrote P equals 75, you can plug that into these equations in here and see which one of these matches and makes P equal to 75. So I highly recommend always double checking your work by plugging in for the variable. Alright, number 7. 100 students go to the cafeteria to eat lunch. 6 tables held the same amount of students while an additional 10 students stood in line. Which equation can be used to find the number of students sitting at each table? So step 1 would be assigning our variable a meaning. So we're going to find x, because they use x in the answers, x equals number of students at each table. Okay, so now we know what x means. So this one seems like we can use our form of b plus mx equals y. Okay, so starting value, rate, variable equals total or ending value. So I'm going to start with my initial starting value, or what's left over. So actually, on this one it might make more sense to start out with our ending value, or our total. So down here, I'm going to write, usually I do this on the right side of the equation, I'll write my ending value or my total. Well, I know my total is 100 students, because it says that many students go to the cafeteria to eat lunch. So I know on the right side of my equation, I will have 100. Then on my left side of the equation, whatever I plug into here, that's going to end up adding up to 100 students, whatever it may be. Okay? Well, if this is all trying to find the number of students sitting at each table, and there's an additional 10 students stood in line right here, we know that 10 students will not be sitting at the tables. So I wouldn't say that's subtraction, because if you subtract 10, you're going to get a different total than 100, because those students didn't go anywhere. They're still sitting. I mean, they're still going to eat lunch. It's not like they left the building or anything. So we can just write 10 right here. So we have the 10 students who were in line, plus the number of students who are sitting at the table. Well, we know that there were 6 tables. And we know that x is the number of students at each table. So if there's 6 tables, we can write 6x. And let's just look at our problem to make sure that makes sense. I mean, at our equation we just drew. So 10 students stood in line, plus 6 tables with X amount of students at each table. And that should equal 100. I believe that does make sense. And our operation is correct. We wouldn't subtract the number of students sitting at each table because we're trying to find a total. So this is an addition problem. And we know it's an equal sign because they say equation. Okay? And the one that pops out immediately to me is A, because that's just our equation flipped from down here. But I'll go ahead and try to make sense of B, C, and D. This is a good thing you can do too, to try to see if these equations down here make sense in terms of this. So this one's saying our 100 students plus 6 tables with the number of students at each table will equal 10. Well, that doesn't possibly make sense. You know, that doesn't even physically make sense. So it can't be B. Let's look at C. So X is the number of students sitting at each table. If we know what X is, where does this 10 come from? We know there wasn't 10 tables, so we already know it's not C. So the X seems good here. Oh, actually, looking back, I made a mistake on A. This was a 10 right here in front of our X, so it cannot be A. Sorry about that. Let's look at D and explain why D is correct. So we know X, number of students at each table. Well, that's the number of students at each table for X. Well, 6, there were 6 tables. So far this is good. Let's look at this plus 10. There was an additional 10 students who stood in line. So the number of students sitting down plus the ones in the line should equal 100. So D makes sense logically. So D is the correct answer. Okay, so now let's look at number 8. A paddle boat company charges A $15 rental fee plus $12.75 per hour for rentals. If Jimmy has $45, which inequality can he use to determine if he has enough money to rent a paddle boat for 4 hours? Okay, so automatically, based just on the answers, but they also tell us that this is going to be an inequality. So we know what symbols we're going to use. It's not going to be an equation, an equal sign. Okay, let's see. So they charge us $15 rental fee. Remember, I said businesses usually charge some kind of initial fee, so no matter how long that you use their service, they are going to make money. Okay? And in our B plus MX equals Y, and I drew an equal sign, but it can also be good. This can be used for an inequality. B is our starting value. So we know out the gate that they're going to charge us $15. So I know that there's going to be a positive 15 right here. Okay? And then right here you see the word plus. So we know that this $15 rental fee is going to be added to some other fee to find the total cost. And that other fee is $12.75 per hour. So we're going to add, and then they give us a rate right here. Anytime you see the word per, that is a rate. It'll be some unit per some other unit. In this case, it's money per hour. And that rate is going to be $12.75. And then let's see what our variable is supposed to mean. If Jimmy has $45, which inequality can he use to determine if he has enough money to rent a paddle boat for 4 hours? So it seems like X is going to be the number of hours. Also, another thing I noticed was that they gave us 4 numbers. This one, this one, this one, and this one. Sometimes they'll give you numbers that won't necessarily be used. And it kind of gives you a hint right here because it says which inequality can be used to determine. So we're not actually plugging in for x, which they tell us right here that we'll eventually plug in 4 for x. We're trying to find the inequality that can be used before we actually plug in the 4 into our equation or into our inequality. So we know x is hours. So if 1275 is our rate per hour, x will be our hours. Okay? Now, and then we know that our the total amount of money that Jimmy has to spend is $45. Okay, now we have to determine which symbol to use. This one is less than or equal to, greater than or equal to, less than or equal to, greater than or equal to. Well, right off the bat, we can eliminate H and G because the rate is not $15 per hour plus an initial fee of $12.75. It's an initial fee of $15 plus a rate of $12.75 per hour. So they flip that on us. So notice how they use the same numbers no matter what. It's just where the variable is and the symbols that are changing. So these can get pretty tricky sometimes. You can't just look at the numbers in here. So it has to be F or G. F or G are the exact same except for the way the symbols are flipped. This one is less than or equal to. This one is greater than or equal to. So if this whole left side over here is going to be add up to the total cost of renting for X amount of hours, and this right side is how much money Jimmy has, let's relate all that back to what we're trying to find out. We're trying to determine if he has enough money. So those words right there, if he has enough money, I would not think of that as, I would think of that as the cost of the ride needs to be equal to or less than how much money he has. If it is over, over the amount of money he has, then he cannot ride the paddle boat. So we can go ahead and eliminate greater than or equal to. The only one that's left that makes any sense is F, less than or equal to. So the total cost of the ride has to be equal to or less than the amount of money that Jimmy has. And that's your answer. I'm going to skip number 9 and go to number 10 because number 9 is actually, I don't like it. The way they set it up doesn't make very much sense, so I'll just skip that so we don't get confused on that. Alright, number 10. Which situation is best represented by the equation below? So sometimes they will ask the reverse of you. They'll give you an equation, and they will give you scenarios that this equation might represent. So on these, you kind of have to go through all of them until you find the right one. So let's look at F. Of the 127 people attending a rugby game, 5 were at the concession stand, B were seated, and 7 were standing up and cheering. What is B, the number of attendees who were seated? Well, the best way we can solve each one of these is to go ahead and write the equation for each one of these and see if it matches what originally was up here. So I wrote the equation for F. And according to F, 127 people were at a rugby game, so I made that my total. I know that 5 were at the concession stand, plus the number that were seated, so which was B, and then plus the number that were standing up and cheering, 7. What is B, the number of attendees who were seated? So using this equation, I can find out B, the number of attendees who were seated. This looks nothing even close to our original equation, so I know F is wrong. So looking at J, and reading J, it seems like they want us to find total. Because it says, what is B, the number of people attending the game? And the total amount of the people at the game is going to be the 7 who were at the concession stand, plus the 127 people who were seated, and the 5 who were standing up. That does not represent, that's not equal to the equation that was originally given to us. Let's look at G. There were 7 players left over after 127 rugby players in a league were divided into 5 teams, with B players on each team. What is B, the number of players on each team? Well, we know that there's 5 teams, and we know that B is the amount of players on each team. So right there, we know that we're going to have a 5B. 5 teams times the number of players on each team. Well, we know that there were 7 players left over. So we know that the amount of players times the number of teams subtracted from the total amount of players, which was 127. So 127, the total, minus the number of players that were assigned a team, there's going to be 7 left over. I'm going to repeat that again. Our total minus the amount of players that were assigned to a team, which is this right here, and then we will equal 7, because we know that 7 were left over. So we know that there's a difference of 7 between these two numbers that are being subtracted. So we know G sounds pretty promising. So let's go ahead and circle that one. Let's look at H. H is almost the exact same thing, except they have a different amount of players left over, and there is a different amount of teams. So it would look similar to this, except the 5 and the 7 would be flipped. But that's not what we have right here. 7 left over, 5 teams. So G is the only one that makes sense. Number 11 is another one of these problems where it doesn't look exactly as the equation you might draw, but what they have as the answer still makes sense. So let's look at this one. The temperature at 7 p.m. was 45 degrees Fahrenheit. From 7 p.m. to 11 p.m., the temperature decreased 5 degrees each hour. Which equation can be used to find T, the temperature at 11 p.m.? Okay. So we know T is the temperature at 11 p.m. That's what all of these T's right here mean. And we know that at 7 p.m., our degrees was 45 Fahrenheit. Okay? So that was our initial. So we can go ahead, and they show you that on all of these. They have a 45 right here. They have it where B would be in our equation, our initial value. Now let's think about what's happening. From 7 p.m. to 11 p.m., the temperature decreased. Decreased. What does that make you think of? Addition or subtraction? Well, I would say subtraction. Okay? So we know it can't be D, because that's the initial temperature plus something. And it can't be C, because that's the initial temperature divided by something. Neither of those are even close to what's going on in here. Decreased does not make me think of any of these. Maybe division in certain scenarios, but not this one. We're not dividing by anything. So let's look at A and B. So T is what we're finding. We know it's an equation. 45 is our initial, and we're subtracting. So all of these are good. So the only thing left is to analyze this part of both of these equations. So one of these says 5 times 11 minus 7. One of these says 11 plus 7. Okay, so let's say we wanted to write our equation with a variable. Or two variables, sorry. So we would have T equals our initial starting point, so 45 degrees, minus the rate, which we lose temperature, so 5 degrees each hour. So that would be temperature equals 45 minus 5 degrees per hour. So this would be hour, and this would be temperature. Well, in this one, they give us a range. They give us a range of hours. They give us from 7 p.m. to 11 p.m. So what they find is, they find that 4 hours passed from 7 p.m. to 11 p.m. So essentially, to find T, it's going to be 45 minus 5 times 4 hours. They don't write 4 in here, but you can figure out which one of these equals 4. You can do 11 plus 7, which is 28. That's not 4. Or you can do 5 times 11 minus 7. And remember, when you subtract like this, you find the difference. So we're finding the difference between 7 p.m. and 11 p.m., which is 4 hours. So 11 minus 7 is the correct way to find that. So A is the only one correct. But even if none of this made sense to you, just because we knew that it was decreasing, we knew it was subtraction was the correct operation, we were able to get rid of C and D. So that gives you a 50-50 chance to get this one right. So remember, always eliminate questions or answers that you know not to be right. Numero 12. Jeff bought a bottle of water for $2. He also bought some hot dogs for $3 each. Jeff did not spend more than $14 on the hot dogs and the bottle of water. Which inequality can we use to find H, the number of hot dogs that Jeff could have bought? Alright, so this one seems like it's fairly simple. We know that it's an inequality. So no equal signs should be in the answer. We know the cost of a bottle of water. We know the price of each hot dog. And we know how much that he could not have spent. Like how much more than he could not have spent. And we know our variable. We know it's H, and we know that represents the number of hot dogs that Jeff could have bought. And there's also some context clues in here that tell us which symbol we can use. So we know that he did not spend more than $14. So if it said if he spent more than $14, that would be greater than or equal to. But he did not spend more than $14, so we know our symbol is going to be less than or equal to. So it's not going to be more than $14. So it can be up to $14, but not over. So that's why we have the equal sign included. So that was our total too. We know $14 is our total. So we have everything we need. So we have the price of water, which is $2 per bottle. He only bought one, so it's just 2. He only bought one, so we're not going to have a rate times the number of bottles. It's just one bottle. So 2 times 1 is just 2. And then plus the price of the hot dogs. Well, those are $3 each. So that's going to be plus 3H. $3 per hot dog. We know our symbol is less than or equal to because it says did not spend more than. That means less than or equal to. And we know the total price of all the items that they cannot go over, which is 14. So we made our equation, and it seems like G is the right answer. It's not the exact same order that we wrote, but that doesn't matter. We will still get the same, this inequality right here and this inequality right here will still get you the same answer. So G is correct. Okay, so let's do a few problems where they give us an equation and we have to write a scenario that matches that equation. So the opposite of what we were doing. So on number 27, our equation is 17 times some number equals 340. So let's go answer choice by answer choice to see what those equations might look like. So for A, the area of a garage floor is 340 square feet. The width of the garage floor is 17 feet. Find X, the length of the garage floor in feet. So for this one, you have to know a little bit of extra knowledge that isn't given to you in this one. You have to know the formula for area. We know that area equals width times length, okay? And they give us the width. We know the width is 17 feet. And they give us the area. The area was 340 feet. So if area was 340 feet, we can plug in 340 for that. And we know that's equal to width, which is 17 feet, times length. And that's what it wants us to find. It wants us to find x, the length of the garage floor in feet. Okay, sorry, so I was supposed to replace w with 17. So 340 equals 17 times L, or you can just put 340 equals 17x. 17 and then x is length. They tell us that x is the length, so instead of using L, you can just use x. And that's 17 times x. So it seems like this equation is matched by the scenario in A. Let's go to 28 now. Which problem situation matches this equation? 74 and 80 hundredths equals 8x, or 74.80 equals 8x. Let's start out with F. Karen got $8 per hour for babysitting. Find X, the amount she was paid for 8 hours of babysitting. Okay, so they want us to find X, the amount. I would say the amount she was paid for babysitting is the total. So I'm going to leave X on a side by itself. And we know how to find it, the exact amount, so we're going to put equals to. And we know that it is equal to the rate, which is $8 per hour, and we know the number of hours, so it's going to be $8 per hour times the amount of hours she worked, which is 8. So that gives us 64, and that doesn't really match what they give us right here. So F cannot be correct. Let's look at G. The cost of a video game is $74.80. So I can go and write that by itself because I know that's a total. Find X, the amount Josh needs to buy the game if he had $8. So scratch that out, and then so he starts out with $8, so I can write that right here. And then X is the amount he needs, so he has 8 plus X, the amount he needs, should equal the total price of the game. So that's the formula, not the formula, but the equation for G. That's still not matching what we have up here, so G can't be right. Let's look at H, and I will do H right here. 8 friends spent $74.80 each to pay for a camping trip. Find X, the total amount they paid. So X is going to be the total, so I'm going to go ahead and put that on the left by itself, because usually the total is going to be by itself. And then let's see, we've got 8 friends, and they spent $74.80 each. Well, that's our rate right there, because it says each. So $74.80 times the amount of friends that went, because it says $74.80 each. So times 8. Well, that'll give us a total amount, but that still does not match what we have up here. So H can't be right. So by process of elimination, J has to be right. Well, let's go ahead and work that out. Charlene got a paycheck for $74.80 for 8 hours of work. Find X, the amount she was paid per hour. So she got a paycheck, so paychecks are usually a total, and that total was $74.80. So I'm going to write $74.80 by itself. We can find that total by multiplying her rate of pay per hour times the amount of hours she worked. Well, we know that rate. Actually, no, that's what we're trying to find, is how much she gets paid per hour. And we know how many hours she worked. So that's going to be 8 hours times X, the amount of money she makes per hour. And it's going to have to equal $74.80. So using these two numbers right here, we can figure out how much she makes per hour. So J properly represents our equation up here. Number 29. Which of the following problems can be solved by using the equation x plus 5 equals 24? Let's go down the answers. So looking at A, Claire had 24 dolls in her collection. She added 5 more to it. how many dolls does she now have in her collection? So we have a starting value of 24, and then she added 5 to that 24. So x, our variable, will be how many does she now have in her collection. So 24 plus 5 will equal x, her new total. That does not represent what's happening right in here. So that's A. And also, if you think about it, 24 plus 5 just equals 29. If you look up here, x plus 5 equals 24. We know x in our problem is going to equal 19. So if your x does not equal 19 in any of these, and that's on any problem like this, then you know it's not right. So if all else fails, just write the equation out for these, solve for it, and see if it matches 19. So B, Lindsay has 5 times as many crowns as her sister. Her sister has 24 crowns. How many crowns does Lindsay have? Well, immediately I know B is not correct because all we have up here is addition. We have x plus 5 equals 24. Well, right here we have 5 times something. 5 times as many crowns as her sister. There is multiplication involved in B when there's none involved in our original equation. So I can go ahead and mark B wrong. Let's look at C. James earned $5 in tips on Monday delivering packages. For the rest of the week, he earned $24 in tips. How much did James earn in tips for the entire week? So on C, James earned $5 in tips on Monday delivering packages. For the rest of the week, he earned $24 in tips. How much did James earn in tips for the entire week? So we're trying to find the total he earned for the whole week. So we can write T for total equals the amount he earned on Monday, which was 5, and the amount that he earned for the rest of the week, which was 24. That does not match what's going on up here, and plus if we found out what the total was, it's 5 plus 24 is 29. That's not 19. So C is wrong. So process of elimination, D has to be right. Let's go ahead and look at it. Alyssa received a gift of 5 fashion magazines to add to her collection. That brought her total number of magazines in her collection to 24. How many magazines did she have before she received her gift? So we know 24 was the amount that her new total was. So 24 equals the amount that she received from her gift. She received a gift of 5. So that gift of 5 added to her collection she already had, so the amount she had before the gift, is going to equal 24. So the new total equals the 5 from the gift plus X, the amount that she had before the gift. Well, that looks very similar to what we have. Let's go ahead and solve for it. So let's subtract 5 from both sides. 24 minus 5 is 19. X equals 19. So not only does our equation match what we have up here, we solve for x and we get the same answer as this equation up here. So we have proven without a doubt that D is the correct answer. Let's look at number 30. The equation below is used to find x. X equals 3 times 20 plus 12. Which equation could be answered using this equation? Which question could be answered using this equation? Let's look at F. What is the total cost of 3 sweatshirts costing $20 each with one on sale for $12? So they give us they say the total cost, so they'll say T equals 3 sweatshirts costing $20 each, so 3 sweatshirts times the cost with one on sale for $12. So we have 3. This is going to give us the price of 3 plus $12. That's the price of one that was on sale. Well, that matches what we have up here, except they chose a different variable, which is okay. You can use whatever variable you want to. I just use T to find total cost. X is just as good. So F is the right one on here. Go ahead and cancel all these because partial one's right.